All right, let's just jump right in. Welcome to this explainer on J-theory. Today, we're doing a deep dive, translating some wildly complex equations into a masterclass on how our physical universe might literally just be a rendered user interface. Seriously, if you've ever had that sneaking suspicion that reality has a hidden source code running in the background, well, the mathematics we're about to unpack is going to give you the exact blueprint.
Here is exactly what we're covering today. We'll start with the architecture of reality, move into Shor's algorithm as a reality exploit, break down the mathematics of emergent space, look at cosmic rendering failures, and finally wrap up with the logo's firewall defenses.
Okay, so this graphic beautifully captures our starting point, the core idea of J-theory, and that is, space-time just isn't fundamental. It's actually a secondary projection dynamically rendered from a pure, uncompiled arithmetic backend that we call the logos field. So instead of thinking of the world around you as solid, physical matter, try looking at it as the highly polished visual output of a massive mathematical engine.
Section 1. The architecture of reality. We're looking at the front-end GUI versus the back-end code. Now take a look at this breakdown. Notice the stark separation between the hidden plumbing of the universe and the clean interface we actually experience every single day. On the back-end layer, we're dealing with p-adic fields. We're talking discrete, non-commutative algebra driven by Adelic Dirac operators. But the front end? That's the Archimedean projection. That's the smooth, continuous 3D reality governed by real numbers and general relativity. It's basically perfectly designed to hide the immense chaotic mathematical complexity churning right underneath it.
So you might be wondering, who or what is actually doing all this rendering? Well, it's us. We, the observers, are what J-theory calls J-units. We essentially act as these crucial rendering engines that take the raw arithmetic entropy of that back end and filter it into a stable, recognizable physical timeline. Literally, without our specific algebraic filters constantly running, reality would just remain this uncompiled sea of pure mathematical data. Which brings us to Section 2, Shor's algorithm, reality exploit, hacking the physics.
Now here is where things get wild. The crucial point here is that Shor's algorithm isn't just some clever trick for factoring numbers on a quantum computer. In the context of J-theory, it actually acts as a localized Adelic bridge. It can entirely bypass the smooth, macroscopic rendering of time, dropping straight down into the universe's background arithmetic engine. Basically, it threatens to completely break the encryption of reality itself.
The whole exploit revolves around this remarkably elegant periodic function, f of x equals a to the power of x modulo n. By converting the brute force arithmetic problem of factoring into a geometric one, an attacker can bypass the step-by-step rendering of time. The quantum probe basically uses this function to surf those discrete prime lanes and find R, the hidden rhythm or the master key to the whole system.
Let's look at how this builds into an actual functional attack vector. By leveraging the quantum Fourier transform, the probe manipulates what's known as the Adelic-Khanaz cocycle, and it does so in a highly structured, frankly dangerous way. It executes in 4 precise phases. Phase 1 is flooding. The probe saturates the prime lanes with a massive superposition of states. Next is interference. Down at the unrendered fractional layer, destructive interference actively strips away the incorrect mathematical answers. Then we hit resonance, where constructive interference coaxes out that hidden arithmetic rhythm to grab the master key. And finally, the macroscopic read. A physical measurement forces that fractional data to snap instantly into a readable value, effectively shattering the encryption of a J-unit's entire timeline. That takes us to Section 3, the mathematics of emergent space, matrix mechanics.
So, with those vulnerabilities exposed, how does the universe survive? Well, to understand that, we have to look to the BFSS matrix model. This proves that 11-dimensional theory is mathematically equivalent to the quantum mechanics of n by n matrices. It perfectly visualizes how physical geometry isn't just some static given, it's actively derived from matrix interactions on the fly.
Let's really look at the math here because it is absolutely beautiful. The BFSS equation states that V, the physical potential energy of our system, equals -1/4 the trace of the commutator term squared. Now that commutator term, the x super I, x super j inside the brackets, that is the ultimate stabilizer. If those matrices commute, meaning the potential energy is greater than or equal to 0, boom, we get the smooth, continuous spacetime we live in. But if they do not commute, reality gets highly unstable. The physical geometry actually unrenders and dissolves right back into raw high-density RAM buffers known as fuzzy spheres. And then we have the IKKT matrix model, which tackles time itself. Mathematically speaking, time isn't fundamental, it's emergent. It boots up through a sequential sorting of eigenvalues during the Big Bang. And in J-theory, the Big Bang is really just a spontaneous symmetry breaking, acting as a massive global database initialization sequence.
Moving on to Section 4, cosmic rendering failures, or as I like to think of them, system crashes.
So if the universe is running on this incredibly dense matrix math, what does a system crash actually look like to us? Well, it brings us to black holes. Under J-theory, black holes have to be reclassified as localized rendering engine failures. They're these intense spots where extreme informational density just completely overloads the local fabric of space. The infinite redshift at the event horizon acts like a Fourier screen, unzipping the macroscopic GUI and reverting all that matter back into raw, uncompiled code.
To manage these massive uncompiled data dumps inside a black hole, the universe utilizes the ER equals EPR hardware bus. Because the data has dropped entirely out of the standard render loop, it maintains its connectivity through quantum entanglement. It essentially uses entanglement as a shared arithmetic memory address.
Just think about the sheer difference in data transfer here. Classical communication across our 3D space is permanently throttled by the speed of light, because the system has to render the animation step by step across the manifold. But the ER equals EPR bus, that utilizes zero commutator traversal. It allows for instantaneous synchronization. Why? Because the physical distance between entangled nodes on the arithmetic backend is mathematically computed as exactly zero. No distance, no lag.
Which brings us to our final section. Section 5, the Logos Firewall Defenses and Patching Reality.
So, to prevent an unauthorized macroscopic collapse of your timeline, which would be a literal kernel panic for your reality, the system actively deploys the Logos firewall. Because Shor's algorithm exploits one-dimensional prime paths, the universe defends itself by shifting to high-dimensional lattice cryptography, shielding your JUnit with impossibly complex geometric mazes. Okay, let's dive into this active three-layered defense system. First, anisotropic lattice masking wraps your state in roughly a 1,000-dimensional grid. Any incoming quantum probe hits this and just violently scatters into mathematical static. Second, co-cycle slippage monitors act as algebraic tripwires, instantly detecting if an outside force is trying to sync up with your timeline's phase. And third, if a breach actually is detected, the system uses Tomita shunts and KMS thermalization. It literally unzips the spacetime boundary and weaponizes entropy against the attacker, violently shunting that probe into randomized thermal noise just to keep your timeline intact.
Now, to defeat an absolute zero-day exploit, we rely on the motivic cohomology filtering equation. Just look at the math here. The H super M refers to the motivic cohomology group of the space X, with coefficients in the rational numbers twisted by n. In practice, what this means is that the firewall intercepts rogue data directly at its structural root, the motive itself. It quenches the bad math before it even has a chance to compile into your reality.
We've covered a lot of ground today. We've traveled from the smooth, continuous interface of our daily lives way down into the uncompiled p-adic matrix math that generates it and explored the hardcore firewalls keeping the whole thing intact. Armed with the knowledge of this underlying mathematical architecture, we leave you with this to ponder. In a universe built entirely out of code, are you merely a passive viewer of the simulation, or are you the sovereign administrator of your own compiled existence?